So here I'll use the coordinate plane and draw these functions out so it's easier to see what's happening. So y equal to 5x, that function is the straight line that goes through the origin. We're only looking at the positive values, so I'll be just focused on the first quadrant. That one is a downward opening parabola, and it goes something like that. It's symmetrical, but we can ignore this side. And what we're looking for is the max value. So for example, if we pick this value for this corresponding value for x here, then this is the value of 52 minus 2x squared. That's on this parabola. And then y equal to 5x is here. We pick the one that's greater. That's what this max means. So that would be one outcome. If we pick a value corresponding to that x, I have to choose the higher one. So that would be that. So I'm essentially generating this function. And you'll see wherever this is above that function, it would take on those values. So if it's here, where 5x is greater, then that would be. So our function really is this. Those values, that's the function. And what we're asked to find is the minimum possible value of the function. And that happens right here where they intersect with each other. And how do we find the intersection? Well, we equate those two, because here both y values are the same, and we can find out the corresponding x value. So that would be this quadratic. 2 times 52 is 104. And I've seen this before. 13 times 8 is 104, and that's a difference of 5. So we can rewrite this as 13x minus 8x minus 52, and then factor in pairs. X, 2x plus 13, factor out of 4, 2x plus 13, and then factor a 2x plus 13. So again, since we're only looking at x positive value, the only solution is x equal to 4, which corresponds to that point. Now we need to find the minimum possible value of the function. We can plug it in either function, x equal to 4, and we'll get the minimum value of that function, which is 5 times 4 is 20 is the answer.